Right. This video is about trigonometry. Trigonometry is a branch of maths which studies the relation between the side lengths and the angles of triangles. Trigonometry can only be used on triangles, but other shapes could be divided into triangles. Trigonometry can be used on 3D objects, as shown in the bottom left. Very interesting. This guy on the right, Mr. Pythagoras, he came up with this theorem that says a squared plus b squared equals c squared. All he's saying really is that the square of the length of the adjacent at the square of the length of the opposite is equal to the square of the hypotenuse. Here we have an example. 3 squared plus 4 squared is equal to 25, and 5 squared is equal to 25. This 3, 4, 5 triangle is a special case. No, my battery is low. Anyway, we'll continue. Yep, just multiples of 3, 4, and 5. That's Pythagoras' triangle, and yep, integers. Next slide. Graphs. Here on the left, we have the graph of sin x. On the top right, we have cos x, and the bottom right, we have tan x. Very interesting. On the left, we have sin x, and you'll notice how it repeats every 360 degrees. Very interesting. Well, cos x is the same, but it's been moved along by 90 degrees. Very interesting. Tan x has an asymptote. That is a point where it does not touch. Here at 90 degrees and 270 degrees as shown on the graph. Very interesting. Next slide. You can read the stuff on the page. I will not. SOHCAHTOA. Here, some triangles. This lets you to find the angles and the lengths. Very useful. You can use this to measure the height of trees and the shadows with measuring equipment. Very useful if you're chopping trees down. Unless it's in the woods, then you won't be able to get a shadow to do it. But if it's a tree in an open field, very useful. So sine, cos, and tan functions can be used when an angle... I messed that one up, but we'll continue. Because I've done all of these slides at once, and I cannot redo just one slide. So we're going to continue. Sine, cos, and tan functions can be used when an angle is used to find the length of another side. This can be done with one side or one angle. Very interesting. Whoever wrote that down. If an angle is needed to be found, the inverse function of sine, cos, and tan can be used. This is often shown as the function to the power of -1, or it's got arc before it. Here is a triangle. So on the next slides, it's going to introduce the sine rule and the cosine rule. And in them, it's got A's, B's, and C's, where capitals represent the angles and lowercase represents the side opposite those angles. So here, in the bottom left, you can see a capital B, and the side opposite, lowercase b. Very interesting. Yeah, as I said, the sine rule. So, A over sine A equals B over sine B equals C over sine C. Or sine A over A equals sine B over B equals sine C over C. So when you're doing this, you won't have all the information to fully fill out that equation. So you can just do it with 2. And here's an example, which you can pause the video and read through. If you're stuck, you could comment, or you could just watch someone else's YouTube video. Here's the cosine rule. A squared equals b squared plus c squared. Well, that looks familiar from somewhere. Minus 2bc cos A. Another example, which you can read through when you pause the video.